given a curve like this, and if we draw a straight line that cuts through a curve like this line is called a secant line. On the other hand, if we have the same curve, but we have the straight line that touches the curve only at one point of the curve, then we say this straight line is called a tangent line. The slope of the secant line is given by 2 points that intersect the curve, namely x1, y1, x2, y2, x2 minus y2 minus y1, or all over x2 minus x1. The secant line, or the slope of this tangent line, could be obtained thus in the same fashion as the slope of this secant line, just that the difference is that the slope of a secant line is kind of like an average. It's not instantaneous slope, but average of what you get from the slope. But the slope of tangent line is instantaneous. It's a slope of that moment, that instant. We could get that by saying that we are moving the secant line to and closer to this one point where the line eventually touches the curve only at one point. We could get that point by using this equation in addition to the limit. For example, limit through another line. So this point is f of x is 1, and this is, let's say, the distance from here to here is h. Then we could say, or let's say it's a delta x for now, because delta meaning change in x. So likewise, the y value associated with the delta x would be x plus delta x. That's intuitive. Okay. Let's erase the limit sign for now and go ahead and use this equation for instantaneous slope of a tangent line. This point would be x and f of x, or x1, y1. This point would be x and f of x plus delta x, or y, or x2, y2. Make this any easier. Let's go. And this is so let's move to here and say here same thing, y2 minus y1 all over x2 minus x1, so which is equal to, let's substitute this, f of x minus, pardon me, it's gonna be y2 being f of x plus delta x and minus y1, which is equal to f of x all over here x2 minus x1. x2 minus x1 is equivalent to delta x, so we'll substitute x2 minus x1 by delta x. So it's gonna be delta x. Now if we leave it like this, it's gonna be a slope of a second line or the average. It's not gonna be instantaneous slope. In order to get the instantaneous slope, we have to use limit, saying that these 2 points will come closer together until they merge into 1 point. In order to do that, we need to use limit. We could do that by saying limit as this delta x approaches 0. Then we could say that it's delta x, meaning this distance becomes 0, then we could get the instantaneous slope. So we could say that the derivative means instantaneous slope of function f. So let's say derivative of function x is the same as derivative of function of x with respect to x is equal to this equation. So this is the general formula for
final 60 seconds.
Instantaneous slope or derivative of function f of x or differentiation.